Hello, boys and girls. Welcome to this presentation. In this presentation, we're going to talk about Unit 5. The key point here says a 2D shape can have lines of symmetry. As we said before, 2D shapes, they have lines of symmetry, in which a line that divides the shape into two identical halves. For example, a square, we said it has 4 lines of symmetry, but a triangle in which that has all the sides equal or equilateral triangle, it has 3 lines of symmetry. But with 3D shapes, we can't say lines of symmetry. We have something else, it's called planes of symmetry, in which a plane looks like that, and it divides the shape into two identical halves, the same idea, because a 3D shape must have a plane to divide it, not a line. Now, planes of symmetry, on either side of the plane of symmetry, the solid is identical. So the plane of symmetry divides the 3D shape into two identical halves. Now let me show you a question, and we will understand more about planes of symmetry. Question 4. In question 4, sketch a copy of each solid and draw in a plane of symmetry. How many planes of symmetry does each solid have? And then discussion which solids have an infinite number of planes of symmetry. Now, first let's take a look at shape A. Now, shape A is a cuboid. This cuboid, we need how many planes of symmetry to divide it into two identical parts? Now, let's take a look at the shape and try to answer it. Very good, we have one in the middle like this. Forgive my drawing, it's not accurate, but let me do it accurately. Okay, here. So it's gonna be in the middle. Yes, I'll try to make it accurate like this. So one in the middle that divides the shape into two identical halves. This is one. And then let me remove it, or let me do it with another color, maybe. We have one here. Okay, I don't know if you get it. Okay, so we have two here, like this. Let me choose another color. So we have one orange, this one, and this one, the green one. And then the last one will be the same as the one in the middle, but vertically, like this. It will be like this. Let me first put it in the middle. Okay, like this. Here to here. And then goes up. And then goes back to this part. Now, as I drew here, I drew 3 planes of symmetry. And these planes of symmetry, they divide the shape into two identical halves or parts. Now, this is for question A. Now, if you don't understand it, let me show you the picture that has the answer and the 3 planes of symmetry. And then we can come back to this. Now, as you can see here in the cuboid, as I said, we have this plane, and this one, and this one. So there are 3 planes of symmetry. You have to imagine it and understand the idea that we put the planes and divide the 3D shape into two identical parts. Now let's take a look at number 2, or B, which is the cube. Now B, which is the cube, let's take a look. How many planes of symmetry do you think we have? Very good. Let's check. We have 1, 2 here. 1, 2, 3, and 1. And we have another one, 4, yes. 1, 2 on top. and 1, 2 on the sides. Very good. So we have 8 lines of symmetry. 8 lines of symmetry. Not lines, planes of symmetry, because it's a 3D shape. Very good. Now let's go back and check the picture that shows the planes of symmetry. Now for the cube, as we said, we have the ones in front. Let's make another color. Here we have 1, as we said, 2, 1, 2, and then, 3 and 4. These ones are from the front. Now the ones on the side, we have 1, as I showed you, 1, 2, and then we have we have 2 on the top, 1, 2. These are 8, yeah. So the cube itself has 8 lines of symmetry, not 9. Let's say it again. So the cube has 8 lines of symmetry. From the front, we have 1, 2, 3, 4. From the top, we have 1, 2. And from the side, we have 1, 2. So cubes have 8 lines of symmetry. Now let's go back to the question and check question C. Now for question C here, this is a triangular prism. Now for triangular prisms, how many planes of symmetry do you think we have? Very good, let's check together. First, we have the 3 on the triangle itself, because it has 3 planes, 3 lines, so it has 3 planes. Very good. And of course, they go back until they reach the end of the line. So they go back like here, and then here, and then here. Yes, like this. So because they are planes, they have to go through the whole shape. That's the idea. And then we have the one in the middle here, in which it's like this. Yes. We put it here. And it divides the shape into 2 identical parts. So for C, we have 4. Same idea for D, because, yes, same idea. We have 1 here. 1 here in the middle. Let me fix it. And 1 here. So these are 2. Yes, 1 here and 1 here. And then 1 here, in which, let me draw it so I can show you. Now you understand the ones in the middle that divides the shape into 2 identical parts. Now let me show you the other one. The other one is from here, like this, and it goes like this. So this one, and the other one is the opposite to it, so it's gonna be like this, like this, like this, and like this. Now let me show you a picture for C and D, so you can understand the planes of symmetry for shapes C and D. Now this one is C. As we said, we have the 3 which are on the triangle itself, and then we have the one in the middle that divides the shape into 2 identical parts. So for C, or the triangular prism, we have 4 planes of symmetry. Now let's check the picture of D. And how many planes of symmetry does it have? Now here we have planes of symmetry for shape D, which is a square-based pyramid. As we said, we have this and this that divides it directly, and this one is diagonal, this and this. So we have 4 planes of symmetry for this shape. And this is how you answer a question like this. Thank you very much for watching. See you next time.